Welcome to this highly critical technical session, focusing squarely on implementing responsible AI across agentic systems. Let us learn how to rigorously govern your AI agents. Welcome to this highly critical technical session, focusing squarely on implementing responsible AI across generative AI and agentic systems. Today, our main focus is on how to govern agent behavior with strict oversight modes, behavioral constraints, and robust tool access controls. When we transition from simple conversational chatbots to fully autonomous AI agents, our enterprise risk profile expands exponentially. Unlike a traditional application that follows highly predictable, predetermined rules, an AI agent operates independently by deeply understanding context, making probabilistic decisions, and autonomously taking actions to achieve specific goals. If an agent is granted overly broad access or lacks rigorous behavioral guardrails, it could inadvertently execute dangerous actions, leak sensitive data, or hallucinate entirely incorrect business decisions. To successfully govern this immense power, Microsoft forcefully advocates a highly rigorous, actionable four-stage process for responsible generative AI: map, measure, mitigate, and manage. You must aggressively map the potential harms relevant to your specific solution and rigorously measure their presence using automated evaluators within the Foundry SDK. However, the most critical engineering work occurs during the mitigate and manage phases, where you actively configure the constraints that physically prevent the agent from causing harm. Governing an agent requires a defense-in-depth, layered architectural approach. We cannot rely on a single security filter. We must establish unyielding behavioral constraints at the system message layer, rigorously secure how the agent accesses external systems via tool access controls, and implement active human-in-the-loop oversight workflows to catch uncertain decisions before they are executed. By embedding these strict governance mechanisms directly into your core architecture, you completely transform your AI agents from unpredictable black box liabilities into highly secure, fully auditable enterprise orchestrators. Let us dive right into architecting these constraints. This configuration maps the four core stages of Microsoft's responsible AI framework. Implementing strict agent governance mechanisms is an active operational requirement directly tied to the mitigate and manage stages of this iterative lifecycle. This visual demonstrates the iterative responsible AI lifecycle. The absolute first line of defense in governing your AI agent's behavior occurs at the system message and grounding layer. While infrastructural content filters are essential for blocking malicious jailbreaks, you must also enforce strict behavioral guardrails directly within the foundational prompt payload. A system message specifies the foundational inputs that define the exact behavioral parameters, professional tone, and strict output formats for your deployed model. By explicitly telling the AI agent exactly what it is strictly not allowed to do, you effectively establish a rigid cognitive boundary. For instance, if you are building an internal HR assistant, your system message must explicitly forbid the agent from providing medical or legal advice under any circumstances. Furthermore, to aggressively govern the agent's factual accuracy, you must establish a firm when unsure policy. By explicitly commanding the model to confidently state "I do not have that exact information," instead of attempting to probabilistically guess, you drastically reduce the severe risk of dangerous hallucinations. This constraint is heavily amplified when combined with Retrieval Augmented Generation, or RAG, via Microsoft Foundry IQ. By using a RAG approach, you actively force the AI agent to retrieve factual, contextual data strictly from your trusted, internal data sources, and you instruct the agent to never answer questions using its base training data. You must rigorously verify these constraints using automated evaluation metrics provided by the Microsoft Foundry SDK. By running automated datasets against your agent, you can mathematically measure the groundedness metric to verify that the agent is respecting your constraints and solely using the provided enterprise data. Combining these strict boundary-setting system messages with verifiable enterprise data grounding creates a remarkably resilient AI agent that safely ignores out-of-bounds requests and never improvises critical business facts. These strict system instructions form an unyielding behavioral guardrail. They tightly scope the agent's persona, explicitly forbid dangerous topics like medical advice, and mandate a secure when unsure fallback response to entirely eliminate hallucinated answers. This diagram illustrates the enforcement of constraints at the prompt layer. Once you have constrained the agent's core reasoning behavior, you must rigorously govern how it interacts with external systems using tool access controls. One of the most powerful features of AI agents is their ability to use tools that extend their capabilities beyond simple text generation, allowing them to perform actions like executing code, searching the web, or calling custom APIs. However, every tool you provide to an agent drastically increases your security surface area. You must implement granular tool access controls using the Microsoft Agent Framework. When an agent decides it needs to execute a custom tool, it does not run your business logic directly. Instead, the function tool forces the model to halt generation and emit a highly structured JSON object containing the specific function name and its exact required parameters. Your application code captures this JSON payload, securely validates the parameters, and then executes the local custom code. By forcing the agent to communicate through these rigid, explicitly defined interfaces, you establish incredibly clear, heavily monitored operational boundaries. Furthermore, data access must be strictly governed. If your agent integrates with the Microsoft 365 Agents Toolkit, you must utilize WorkIQ. WorkIQ acts as a secure, intelligent bridge between your custom AI agent and your organization's protected data graph. It natively enforces user-delegated access controls, meaning that when a user asks the agent to summarize emails, the agent only retrieves data that the specific requesting user is explicitly authorized to see. This user-delegated access model aggressively prevents the AI agent from acting as a dangerous bypass mechanism around your existing corporate security boundaries. By diligently auditing tool implications in your trace logs and restricting data retrieval to authenticated pathways, you completely guarantee that your agents respect all document-level permissions. This JSON payload represents a governed tool invocation. The agent cannot randomly query the database. It must output a specific tool name and validated arguments. The application acts as a security gatekeeper before executing the actual function. This flow highlights the auditable tool execution process. The AI agent generates a structured JSON payload. The application strictly validates this payload as an access control gatekeeper before safely executing the code against the real-world API. While strict system messages and granular tool access controls provide excellent baseline security, highly complex or sensitive business processes demand active, real-time governance. This introduces the absolute necessity of implementing human-in-the-loop oversight modes using agent-driven workflows in Microsoft Foundry. Workflows provide a declarative, visual way to orchestrate AI agents, combining advanced reasoning with rigid, deterministic control flow. Because AI agents are inherently probabilistic by design, they will inevitably occasionally encounter highly ambiguous requests or generate outputs with very low confidence scores. To manage this systemic uncertainty securely, you must proactively apply human-in-the-loop and escalation patterns directly within your workflow architecture. An approval workflow acts as a mandatory, secure checkpoint. For example, you can utilize structured agent outputs to evaluate the agent's confidence level. If an agent is analyzing a customer's refund request and its calculated confidence score falls below your strictly defined quality threshold, the workflow must actively halt the autonomous execution. It then securely escalates the structured JSON payload, alongside the agent's proposed action, directly to a human operator's queue. The human operator thoroughly reviews the agent's reasoning, examines the attached data provenance metadata and citations, and makes a final, authoritative decision. Only after the human explicitly approves the action does the workflow resume and execute the final API call. By implementing these rigorous escalation patterns, you drastically reduce the risk of catastrophic autonomous failures. You ensure that highly sensitive business processes always remain strictly under human supervision, while still benefiting from the immense speed and analytical power of the AI agent, creating a highly resilient, fully auditable operational framework. This logic demonstrates a critical escalation pattern. By evaluating the agent's confidence score, the workflow automatically intercepts uncertain decisions, forcing a secure human-in-the-loop oversight review before any system modifications occur. This diagram showcases the human-in-the-loop approval mechanism. Actions with low confidence entirely bypass autonomous execution, escalating directly to a human operator who reviews the contextual data before approving or rejecting the workflow. Beyond explicit human-in-the-loop checkpoints, you can also govern agent behavior by structurally limiting their autonomy through specific agent orchestration patterns. When using the Microsoft Agent Framework, you rarely want a single, monolithic agent handling an entire complex enterprise process, as a single agent with too many tools becomes incredibly difficult to constrain safely. Instead, you orchestrate a multi-agent solution where each agent is highly specialized and strictly bounded. For highly controlled environments, you should utilize sequential orchestration. In sequential orchestration, agents are arranged in a strict pipeline where each agent processes the task one after another. The output from one agent becomes the input for the next. Because the order in which agents run is entirely fixed and decided beforehand, the agents themselves do not decide what happens next, drastically limiting their operational freedom and maximizing your architectural oversight. Alternatively, for scenarios requiring dynamic delegation, you can use handoff orchestration. Here, agents can transfer control to one another based on the task context, ensuring the best-suited agent handles each specific part of the task. By keeping each agent narrowly focused on a single domain, such as having one agent solely for data retrieval and a completely separate, isolated agent for formatting the final response, you naturally enforce the principle of least privilege. Even more complex patterns, like magentic orchestration, utilize a dedicated manager agent to coordinate sub-agents while maintaining a shared context and a dynamic task ledger. This task ledger acts as an immutable record of goals and execution plans, further enhancing your ability to audit the system's reasoning. Strategic orchestration is a powerful form of structural governance that inherently restricts the scope of potential failures. This configuration enforces structural governance. The data underscore retrieval underscore agent has search permissions but no formatting logic, while the formatting underscore agent cannot access external APIs. This isolation strictly contains the blast radius of each component. This visual contrasts monolithic agents with sequential orchestration. Rather than giving one agent full access, a sequential pipeline structurally limits capabilities, securely passing data from a retrieval agent directly to a specialized formatting agent. In our final slide, we synthesize these powerful governance concepts into the ultimate stage of the responsible generative AI lifecycle, the manage phase. The manage stage dictates that you must govern your agentic AI solutions responsibly by defining and meticulously following a comprehensive deployment and operational readiness plan. You cannot simply configure your system messages, tool access controls, and human-in-the-loop workflows, and then deploy the agent globally on day one. Instead, a cornerstone of responsible operational readiness is implementing a phased delivery plan. A phased delivery approach involves releasing your AI agent to a small, highly controlled pilot group first. During this crucial pilot phase, you aggressively audit the generated trace logs in the Foundry SDK to verify that the agents are invoking their custom tools correctly and entirely within bounds. You closely monitor the real-world frequency of your human-in-the-loop workflow escalations. If your human operators are constantly required to override the agent's proposed actions, your live telemetry clearly indicates a massive flaw in the agent's underlying system instructions or tool definitions. You must use this real-world, highly objective feedback to iteratively refine your prompt engineering strategies, tighten your content safety guardrails, and retune your conditional workflow routing logic. Responsible AI is an ongoing, dedicated commitment to continuous improvement and relentless operational vigilance. By heavily instrumenting your architecture with these robust governance mechanisms, you ensure your enterprise AI systems remain exceptionally secure. Thank you for joining this session. Please like, subscribe, and visit quicktechie.com for premium certification prep, including massive Q&A banks, comprehensive ebooks, expert audiobooks, and exclusive interview guides. Keep building responsibly. This configuration enforces a phased delivery strategy at the infrastructure level. By routing only 10% of real-world traffic to the new autonomous agent, engineers can safely audit trace logs and evaluate governance controls before global release. The continuous management lifecycle. A phased pilot release generates deep telemetry. Security teams actively audit trace logs and workflow escalations to identify governance gaps, iteratively refining system constraints prior to a secure global deployment.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.